Okay, this is Chemistry Chapter 6, Lecture number 2. You'll need to have your notes ready. We're going to start with On Your Own 6.6. You'll want a periodic table handy, a calculator, and in the book, turn to page 182. We're going to work 6.6 on the bottom of page 182 to start out. All right, so in this lecture, what we're going to do is, in the last lecture, we just went from moles A to moles B. Moles of substance A to moles of substance B. We call that part stoichiometry. However, we can convert from grams of substance A to grams of substance B by using the molecular weights in the periodic table and doing the grams to moles conversions that we did in Chapter 5. So reading through 6.6, it says the insecticide DDT, okay, that's this. I went ahead and labeled it DDT, which is now banned because of its deleterious environmental effects, was manufactured with this chemical reaction. I wrote that out for you. If you need to pause the video to write this out, go ahead. If 486.1 grams of C6H5Cl are reacted with this reactant here, C2HClO3, how many grams of DDT will be produced? All right, so I like to, again, write the number write what I know underneath the compound, and then put a question mark in the one that I'm going to, so I don't accidentally convert to this or to that. It just helps me see what I'm doing. So you always start out, let's start on the far left of your paper. Start out with 486.1 grams. Put it over, and this is, C6H5Cl. Put it over 1. All right, we're going to have to, before we can go to moles and then grams of DDT, we've got to switch to moles of C6H5Cl. Okay, so moles C6H5Cl. All right, sorry if that's a little messy. I'm going to have to write small to get it all on this sheet, but hopefully you can see what we're doing. And then we're getting rid of grams of C6H5Cl. Now, in this case, we are converting from grams to moles. You remember the 1 always goes by the mole here. Where do I get grams of C6H5Cl? I get it by adding up the molecular weight or the molar mass of C6H5Cl from the periodic table here. So we've got 6 carbons, so 6 times 12. I've got 5 hydrogen, 5 times 1, and then 1 chlorine, and chlorine is 35.5. So if you add those up, you're going to get a molar mass of 112.5 grams. Now we can go to moles of substance B, and that is the stoichiometry. So I've got moles of this compound, C14, H9, Cl5. I can get rid of moles, just go up and to the left, moles of C6, H5, Cl. Okay, so this is the stoichiometry part. So we just use the coefficients. So the coefficient in front of the C14, H9, Cl5 is 1. The coefficient in front of C6H5Cl is 2. So 1 and 2. And now we can finish the problem up, go to grams of C14, H9, Cl5. Get rid of moles of C14, H9, Cl5. where the 1 always goes by the mole. And then we have to add up this compound. So it's each carbon weighs 12 from the periodic table, 14 times 12, plus 9 times 1, 9 hydrogens, plus 5 times 35.5. That's a pretty heavy compound, 354.5. So I'm rounding to the nearest tenth. So if you use the periodic table in the front of your book, that rounds to the nearest tenth. Or if you want, you can take this that's in hundredths place and just round it to the nearest tenth. There, you'll get 354.5. You don't have to go all the way out to the hundredths place. All right, so in your calculator, okay, so we have 486.1. We're going to divide that by 112.5. I like to hit equal, okay? And then I got a number. Then divide that by 2, because we've got a 2 on the bottom. And then multiply that number by 354.5. So 765.9 grams of the DDT, which is C14H9Cl5. All right, so that's going, we were able to go all the way from grams of substance A to grams of substance B. The chemicals that the compounds that the author used are pretty long. You know, you might not always have that, especially on the test. They'll probably give you shorter compounds so that's easier to fit. All right, but so I realize this is kind of, you might have to write a little small to fit this in your notes. All right, let's go on to 6.7, which is at the top of 183, just over one page. We've got 2 more of these problems where we're going from grams to grams, and then I'll teach you one last little thing. All right, 6.7, the chemical equation is 7H2O2 plus N2H4, and that yields 2HNO3 plus 8H2O. Try to be a little neater there, sorry about that. So a rocket engine has 11.2 kilograms of N2H4. So again, we're at the top of page 183, 11.2 kilograms. Let's go ahead and change that to grams, 11,200 grams. What's the minimum mass of H2O2? So put a question mark. Mass means grams. So we're going from grams of N2H4 all the way to grams of H2O2. So let's start on the left here. 11,200 grams of N2H4. Put it over 1. Got to convert to moles of N2H4. All right, I am canceling out grams of N2H4. When you have moles in something else, a different unit other than moles, the 1 always goes by the mole. Adding up N2H4 from the periodic table, there's 2 nitrogens. Those weigh 14 each, so that'd be 28, plus 4 times 1 of hydrogen, so that's 32. All right, feel free to use your calculator. Now we're here. We want to go from moles of N2H4 to moles of H2O2. Right, moles H2O2. Going to cancel out moles N2H4. Here we use the coefficients in the reaction. All right, so 7 is in front of H2O2, and 1 is in front of N2H4. So now we're at moles of H2O2, we're at moles of substance B. Let's finally go to grams of H2O2. we're going to cancel out moles of H2O2. 1 goes by the mole. Let's add up from the periodic table the molar mass of H2O2. It's going to be hydrogen 2 times 1, that's 2, plus 16 times 2 is 32. That'll be 34. So in your calculator, do 11,200. Divide that by 32. I usually then hit the equal sign. Multiply that number by 7. And then multiply that number by 34. All right, and the answer you should get is 83,300 grams of H2O2. I may have rounded that. Let's see real quick. 11,200 divided by 32 times 7 times 34. No, it's exactly 83,300. Okay, so I didn't even round that one. All right, let's see if I can fit 6.8 underneath here. So 6.8, we have CaC2 plus 2H2O. That makes CaOH2 plus C2H2. All right, reading through that, we have 100 grams. It says that acetylene is C2H2. Okay, so you have to read and see what it is. We have 100 grams of acetylene, and we want to know how many grams of water. So I'm going to put a question mark there and how many grams. All right, so let's start over at the far left, 100 grams of C2H2. Put it over 1. We have to convert that to moles of C2H2, so I know the 1 goes by the mole. Adding up C2H2, 2 times 12 is 24, plus 2, that'd be 26 grams of C2H2. We want to go to moles of H2O. Okay, we want to cancel out moles of C2H2. Okay, looking at the coefficients, in front of H2O we have a 2. In front of C2H2 we have a 1. And finally we want to go to grams of H2O. Get rid of moles of H2O. We know the 1 goes by the mole. Adding up the grams of H2O, that's going to be 16 for oxygen plus 2 for hydrogen, so 18. All right, so 100 divided by 26 times 2 times 18. All right, that will give you 138.5 grams of H2O. Okay, so those are our 3 stoichiometry examples where we're going all the way from grams of one substance to another substance. Okay, so to finish up this lecture, I want to talk about empirical and molecular formulas, and we are on page 5 in the notes, so right beneath 6.8 that you just worked. Okay, here we can go ahead and get rid of our stoichiometry equation. Okay, a molecular formula is what we've been working with so far. It's a chemical formula that provides the number of each type of atom in a molecule. So that's H2O. That's everything that we've been doing so far. An empirical formula is the simplest whole number ratio of atoms. So what we have to do is take a molecular formula and reduce it to its mathematically simplest form in terms of number of atoms. Okay? And there's a reason that we're going to do that. Okay, and it's I'm going to explain that to you in the next lecture. All right, so let's go to 6.9, and that is on page 186. So the instructions for 6.9, which of the following molecular formulas are also empirical formulas? If the formula is not an empirical formula, write the empirical formula for that molecule. So the first one, A, is Al6O9. Okay, so we're just looking at the numbers here, 6 and 9. That's not in its simplest form. The greatest common divisor of 6 and 9 would be 3. So we can reduce Al6O9 if we divide both numbers by 3. That's going to be Al2O3. So that's our empirical formula. The simplest form, Al2O3. B is PbO2. So we have one lead, one oxygen. You can't reduce that anymore. The greatest common divisor between 1 and 2 is just 1. So that's already empirical. That's okay. Empirical and molecular formulas can be the same. So in this case it is. Part C, MgCO2. So we have 1 magnesium, 1 carbon, 2 oxygens, 1, 1, and 2. You can't reduce that anymore. The greatest common divisor in this case is 1. So it's also already empirical. No reduction needed. All right, for D, we have C8, H18, O2. Okay, that's not in its simplest form. We could divide each of those numbers by 2 and reduce it. The greatest common divisor of those 3 numbers is 2. So we could reduce that down to C4H9O. So that's our empirical formula. The last one, part E, Si3, H9, O2. The greatest common divisor of those 3 numbers is 1. That can't be reduced. Okay, 3, 9, and 2. You can't come up with a number that you can divide all 3 of those evenly. So it's already empirical. Okay, so that concludes lecture number 2. The homework for this particular lecture, go ahead and erase this. Pause if you're still writing. The homework for this particular lecture is review question, page 198, 6 through 8, and practice problems, page 199, 5 through 7. Now, one thing that I want to alert you to on these first 7 practice problems, if they don't give you the chemical equation, okay, let's say they say it's a combustion reaction. That means you have to use your knowledge from prior chapters to write out the combustion reaction, and you have to balance it yourself, okay? So that's going to be true on the practice problem number 1. It says you have a combustion reaction, so you have to write out the combustion reaction, balance it, and then do the stoichiometry, okay? All right, that concludes lecture number 2, and I will talk to you next video.